If we want to combine different type of information collectively to represent real world instances, then in C++ we have two choices. We can either use a structure, in short struct, or we can use a class. However, the structural construction of struct and class are quite similar, and therefore oftentimes we get confused which one to use in which context. In this video, we are going to clear that up. Coming up. Hey, this is Subrata Kumar Dey. I am a university teacher teaching computer science courses over 1.5 decades. If you are a coding enthusiast or new to this channel, consider subscribing and please press the notification bell so that you don't miss any update. Well, in today's video, first we'll talk about why we need a structure and class, what are the components of structure and class. We will also talk about the accessibility mode of the members of a class, and finally we'll talk about when to use what, either structure or class, in which context. So please watch till the end to get the overall idea of the video. First of all, let's talk about why we need a structure or class. Think about a scenario where you need to deal with 10 integers. So we can actually declare an array of integers where all the elements are of homogeneous type, in our case integers. So if we declare an array, we actually make a collection of homogeneous data. But we cannot store different types of data in an array. However, the real world instances have information associated with it. Oftentimes they are of different types. So one of the main purpose of using class or structure is to allow us to create a collection of heterogeneous data type. For example, a student can have a student ID, student name, student CGPA, and all three can have different data types. ID can be integer, name can be string, CGPA can be float. So to make a collection of these three pieces of information, we have to use either a structure or class. That's one motivation of using structure or class. And whenever we define a structure or class, it automatically becomes a user-defined data type. Okay. Now let's look into the components of a class or structure. Of course, the data that we are using to make the structure or class are components. So we call them member data, and there is a name to call them. Oftentimes we call them fields. Okay. So if we say student is a structure, then student ID, student name, and CGPAs are fields. If we declare an employee as a class, then employee ID, employee name, employee designation, employee salary, these are all fields of employee class. So a structure or class can have fields which represents the data. We can also add functionality to the class by adding member functions to the structure or class. What it means? For example, if we consider a student structure or employee class, now for a student, as fields it can have many grades. All the grades achieved by the student can be the data, that means they can be fields. However, a student should be capable of calculating its own CGPA. So we can add a member function to the structure or class, and that member function can be called to calculate the CGPA of that particular student. So we are empowering the object by means of calling the functions to do something for the data of that object, okay, fields of that object. So that is member function. There are a special type of member functions available for structure and class as well, and we call them constructor and structor. Now constructor actually constructs an object. What does that mean? An object is a structure or class variable, and construction of an object means when the memory is allocated for that structure or class variable, since they are data type 2, their fields should not be garbage. So unless we assign some value to the fields or take the user input for the fields, they will typically have garbage. So the constructor can be written to prevent having garbage at any point of time. So the moment an object is declared, memory is allocated, the constructor will be fired and it will assign some default values to the fields. To understand more about the methods and the fields and how they can be accessed, we also need to understand the accessibility modes. In C++, we have three types of accessibility modes: private, public, and protected. Before I talk more about this, let's look into the source code and explain the things with the help of the source code. So if you look at the screen, I have created a student structure. So struct student opens with second bracket and ends with second bracket semicolon. So that is the whole structure. Okay, and if you see here, the student structure has three fields: SID, SNAME, and CGPA, two representing student ID, name, and CGPA. I have also created a class called employees. So instead of struct, now it is class. So class employee, and there are again three fields: employee ID, employee name, and salary, to represent ID, name, and salary of an employee. Now we also added some member functions, added some functionality to the structure, to student structure and employee class. So for a student structure, we have added set student info, show student info, and there is a constructor. Now constructor is a special type of method which has the class name. So class name is class or structure name. So structure name is student, so therefore the constructor is also student. Also there is a method called do assignment, which is capable of doing assignment for a student. Now in structure, all the members, whether it's a field, which is the member data, or methods, which is member function, by default all of them are public. So by default for structure, the accessibility is public. Okay, so therefore all the three fields, SID, SNAME, CGPA, and all the methods called set student info, show student info, constructor, and the do assignment, they are all public. However, we have intentionally added a member function, a method called conduct survey, as private. So we use that private colon. That means hereafter everything is private. Now we never used private colon before, so up to this point everything is public. Now what does that mean, public or private? We are going to talk shortly. Now let's see what is there in the class employee. So in class employee, by default everything is private. So therefore all the fields EID, ENAME, and salary are private. Now if we don't put the public colon, then all the constructor, set employee info, and show employee info also becomes private. So right now, according to the source code that we are viewing on the screen, all these three fields are private, and also all three methods, so two methods and the constructor, are also private. So what are the implications or consequences we are going to see? Okay, now for time being I'm making it public. So what happens when a member is public, then that member is accessible from outside of the structure or class. Okay, now in our case, the student as well as the employee are types, because student is a structure and employee is a class. So therefore we can declare variables of these types from anywhere. So suppose in the main function, the way we declare an integer int x, we can actually declare a student object, student variable s1. So we are declaring an object student s1. Okay, so s1 is the structure variable, which is an object, and employee is a class, so we also declare an employee object e1. So in line 50 we declare a student object, and in line 52 we declare an employee object. So that's fine, no problem. Now for time being, ignore line 51 and 53. I'm coming there. Now S1 is an object. Now let's say John is a student. So John has a student ID, student name, and student CGPA. So in our case, S1 has SID, SNAME and CGPA. However, suppose the CGPA is a float. If you look at the structure definition, CGPA is a float, but it's not an independent float. If you declare a ordinary x, independent x in main, you can say x equal to 10 or C in x. But I cannot simply say CGPA equal to something or C in CGPA, because CGPA is not an independent float. It's a field of the structure student. So therefore, I need to tell that it's a field of the class student, but this field is stored for an object. So in our case, S1 is a student object, but the CGPA is a field, so we have to access the CGPA S1 dot CGPA. Okay, so if you look at the line 55, we are printing CGPA of S1, and then we are actually accessing the field CGPA using the object S1. So S1 dot CGPA. So dot operator actually indicates that we are going to use a member of that structure or class object. Okay. Now we can do this if and only if the CGPA is public, because we are trying to access the field or the member data from main function, which is not part of the class or structure. So main function is an outsider. So main function as an outsider is trying to access a field of an object, so therefore the field has to be public. Now as I said, in structure everything is by default public. Okay, so therefore this is accessible. Okay, so this is accessible. So if I print that, it is absolutely perfect. However, for employee, if I just say salary of E1 is an employee object, and if I try to access E1 dot salary, the field salary from the object E1, I will have a compilation error, because in class by default everything is private. So if you look at the class definition above, in line number 31, you see that employee ID, EID, ename and salary, they are by default private. Okay, so if I try to build this, it will give me an error. Okay, so the error is, if you see here, the salary field of employee class is private. Okay, so it means since it is private, I cannot actually access the salary field of an employee from main, because main is an outsider. Okay, so for S1.CGPA it is fine, but for E1.salary it is not fine. Okay, so what can we do? We can declare the salary as public, so I can actually declare all the fields as public as well, and now that error is gone. So it builds successfully. Okay, so it builds successfully. Okay, so that is the thing. So if a member of a class or structure is public, they can be accessible from a function which is not part of the class or structure. On the other hand, if a field is private, then it cannot be accessed from a function which is not part of the structure or class. Now let's talk about the methods. That means the member functions. Now in student structure we have several methods. For example, set student info, okay, show student info. So they are part of the structure, but by default they are public. So we can call these methods from main. Okay, so main is an outsider, so main is the caller, so main can call them. Now they are not a normal global function, they are a member function. So again we have to use the dot operator to represent that it's a member, and we are using the object S1 to call this method. Okay, so main is calling set student info by specifying S1 is the client. Okay, client object for this particular call. Now set student info is again called in line 63. Now in this second call, the caller main function is specifying S2 as the client, which is another student object for the second call. Okay, so why we are specifying an object to call a method? That is required because we need to specify which object is the client when we call a method. So a particular method of a class or structure can be called 100 times, but the client can change each time. So a different call, different object can be clients. For example, if I say John.calculate CGPA, so CGPA, calculate CGPA is a method of student structure or student class if it is a class. But for this call, John is the client. Now we can also say Sonia.calculate CGPA. Now again, same calculate CGPA method is called, but in the second time Sonia is the client. So calculate CGPA method will use the fields of the client to calculate the CGPA. So if we say that John is the client for the first call of calculate CGPA, then calculate CGPA will use the grades, which are field from the object John. On the other hand, if we say Sonia.calculate CGPA, then calculate CGPA method will use the fields to calculate CGPA for Sonia by using the grades from the object Sonia. So that is why a method is potentially a method can potentially use fields, and therefore we need to tell the fields from which object. So that is why we need to provide an object as a client. That is not the case for 100% of time because a method can be static, but that's beyond the scope of the discussion of this video. Okay, so if you are interested to know in detail about the static methods of a class or class, then stay tuned for upcoming videos. Okay, so now we have another access modifier called protected, but that is also we are not going to discuss in this video because to understand protected we also need to talk about the inheritance, which is a different object oriented topic that we'll cover in a later video. Okay, now if we look again into the main function, we have declared a S1, which is an object of structure student. We have declared E1, which is an object of class employee. However, we can treat the structure student as a class and declare an object. So we declared S2 as an object of class student, though the student is defined as a structure, but now we are treating structure student as a class and declaring an object S2. Same thing we can do inversely for a class. So employee is a class and we have declared a class object E1, which is an employee object. However, we are declaring another employee object E2 but as a structure object. So we are treating the employee as a structure to declare the object E2. So we can actually interchangeably treat a structure as a class or a class as a structure. And it works because if you see, we are printing CGPA of S1 and CGPA of S2. They will print the CGPA of S1 and S2. Also, if we want to print the salary of E1 and E2, they will print salary of E1 and E2. Now, one thing to be noted, in structure by default the field is public, so even though we treated student as a class for declaring E2, the fields of S2 for S2 the fields of S2 remain public. On the other hand, for class the fields are by default private. So even though we treated employee as a structure to declare the object E2, but the fields of E2 still remain private. Okay, and that is why these two statements will give us error because the fields of employee class are private. Okay, but if we make them public, then we can. Okay, so let me comment this and I'll come back here later on after talking about the constructor. Okay, now if we analyze these lines in the main function from line number 60 to 67, you will see that we are calling set student info and show student info two times. For the first time for the client S1, student S1, and for the second time for the client object S2. So set student info will be called twice, but for the first time it will take input for the fields for S1, and for the second time it will take user input for the fields for S2. And same thing for show student info. So it will show the values of fields from the client object S1, and it will display the values of the fields from the client object S2. So therefore inside the method we don't need to tell which object it should consider to read or write the fields, because whichever is the client, it will treat that object to read or write the fields. Okay, so in set student info we are asking the user input for SID, SNAME and CGPA, but from which object? Okay, well, for the first call, if it executes for the first time, the S1 is the client, so these fields will be associated with S1, and when it called second time, these fields will be associated with object S2. Same thing for show student info. Now we are doing the same thing for employee class also. In employee class also we have similar methods. Okay, set employee info and show employee info, and of course they need to be public, because otherwise we cannot call them from main. Okay, so for any member to be accessible, now when you say a field is accessible, it means we can read from that field using a client, okay, s1.cgp, or we can write into this field. When you talk about a method is accessible, it means we can call that method. Okay, so we can call s1.set student info, or in case of employee you can say e1.set employee info. So we are able to call, we means the main function, the caller function is able to call the method for a client if the method is public, and that is why in employee class we made the methods public. Okay, and we on principle we should make the by default, if we don't say anything, the fields are private. So that is why in structure we don't need to tell anything about the private public, because by default they are public, so by default they are accessible to main. But in case of class we need to make the methods public so that these methods can be called from main. Now whether the field should be public or not, by default it is private, but if we want to we can, but we shouldn't, because the class has a purpose, that means keeping the data protected from direct access to outside world. So if we want to adhere to that philosophy, then we should keep the fields as public. Okay, so now the fields are public in the employee class and the methods are fields are private in the employee class and the methods are public. Now that's fine, because we are not manipulating the fields now. Right now we are only calling the methods, so all the methods are public. So if we build and execute, we'll see that it is working. So student ID, let's say 11, student name, let's say John, CGPA, let's say 3.1, and it is showing the information of John from the fields. And then again for S2, now we are taking the inputs, class object S2. So let's say 22, let's say Sonia, and 3.2. Okay, and now it is showing the field values of S2. Now we are doing the same thing for employee E1. Now let's say E1 is 111 ID. Okay, so Stephen is the employee name, and let's say salary is 1 lakh, and it is showing the field values from the employee Stephen, and let's say the employee ID, second employee ID is 222, and let's say the name is Raju, and the salary is 2 lakhs, and it is showing. So it's perfectly alright to treat structure as a object and object as a structure, and it's working because we are calling the methods which are public. Okay, now if we want to print the fields directly before we call the set student info show student info and set employee info and show employee info. Now suppose we are trying to print the CGPA of students S1 and S2 objects and the salary of employees E1 and E2. What will happen? So as you see, by default the fields are public in structure and by default the fields are private in class. Okay, so if I try to build, now it is giving an error. Okay, so the error tells that the salary field of employee class is private. Okay, so the main is an outsider and main is trying to access the private field of employee class, and this is not allowed. Okay, and that is why I commented these 2 lines, or in fact these 4 lines, because it will not compile. Now of course we can declare that the fields of the class also public. Now it will work. Okay, and okay, it built successfully, as you can see. And if we execute, now it is printing, okay, CGPA of S1 is 0, CGPA of S2 is 0, salary of employee 1 E1 is 0, salary of E2 is also 0. So it is actually accessing the private fields of public fields of E1 and E2. So now both for structure student and class E employee, the fields are public, so it is accessible. Now why it is 0? Because we have created a special method called student in student structure and method employee in class employee. So if the method name is same as the class name or structure name, we call that constructor method. Okay, so constructor is a special type of method which constructs the object. So what it means? It means, now think about the student structure and employee class. We have some fields, okay, employee ID, student ID, name, okay, CGPA, salary, etc. Now in main, if you see here, we are declaring the object S1. So memory is allocated for student object S1, same thing for S2 and also for employee objects E1 and E2. But how about the field values? Okay, memory is allocated for the objects. That means every object has some memory to store the field values, but those field values are garbage. Okay, so if we don't define any constructor, now let's say, let me comment the constructor. Okay, in case of employee, so I am commenting out the constructor for employee as well as for student. And if I build again, and now if I print the CGPA for S1, S2 and salary for E1, E2, now you can see some garbage values. Okay, okay, so we can actually prevent the garbage values. So constructor means construct the object. It means the moment the memory is allocated for the object to represent a real instance, all the field values are set with some default values. Okay, so instead of garbage, it replaces the garbage values of those fields with some predefined values. Okay, and that's called construction of the object. So therefore, if anytime if you access those fields without assigning some value or without taking user input, you will get those default values. Okay, so in the student constructor, what we did, we assigned 0 and 0 to student ID and the CGPA and a string called TBA, to be announced, as the student name. Same thing we did for employee class constructor. So employee ID and salary is 0 and employee name is TBA, to be announced. And now if we print the employee salary or student CGPA, now instead of garbage, the constructor actually, so whenever we declare S1, the constructor is fired and it sets the student ID and CGPA as 0 and 0.0. Same thing for employees. Okay, employee ID 0 and employee salary as 0.0. And that's why now if we build again and print, we'll see 0, 0, 0, 0. Okay, so that's the constructor. And constructor do not have any return type, not even void, okay? Because as we discussed in previous videos on functions, if you have not seen those videos, please check out the card somewhere at the top. As we discussed, that whenever a function is called, after executing its statements, it needs to return back the control to its caller function. So void means returning the control alone, and if return type is int, then you are returning a number with the control back to the caller. Now constructor is not called because it does not wait to be called, okay? So the initialization of the field values should be spontaneous, okay? So at the very moment memory is allocated for that object, constructor cannot wait to be called, so it has to assign the default values. That's why constructor is not called. And since constructor is not called, there is no question of returning the control back to the caller, and that is why there is no return type for constructor. So in case of class employee, there no return type for employee constructor. Same thing for student constructor in case of structure student, okay? Fine. So that is why now we see 0, 0, 0, 0. Okay. Now let's say we declare another student S3, and now we can call do assignment, because there is another method in the student structure which is public method called do assignment, okay? So we can call do assignment for S3, okay? So now let me comment this out to just save the time. Okay, so now we have S3. So now we have S3 and we are calling show student info. So no set student info is called for S3, so it will show the default value set by the constructor, which is ID as 0, name as TBA, and CGPA as 0.0. And now we are calling do assignment, okay, which is a public method in the student structure. You see the do assignment is a public method, so it will print doing assignment, okay? So let's check that. Build successfully. Now it is printing the default value set by the constructor. So student ID is 0, student name is TBA, student CGPA is 0, and the do assignment is printing doing assignment. However, if we want to call the method called conduct survey in the student structure, it also same for the class. So can I do that? So if I say s3 dot conduct survey, and if I try to build, I cannot do that because conduct survey is private method, okay? So that is why conduct survey is not callable from main, okay? Now the question might come in our mind, okay, so if the method is not callable from outside, what's the point of having that method at all? If we can't call that, if some function or method can't call the method of the class as because it's private, then what's the point of having a private method? Well, the answer is the private methods are typically acts as a helper method for some public methods. So outsider will actually call the public methods like do assignment, okay? So as a main function or a function of some faculty class, method of some faculty class can call a public method of student, let's say do assignment, okay? That's fine. So a student is asked to do an assignment. Now conducting survey may be a internal requirement of doing that assignment, okay? So the caller will never call to conduct a survey. Caller will call to do an assignment for a student. So do assignment is a public method. However, as part of the doing the assignment, it may need to conduct a survey. So do assignment can call the conduct survey. So private methods can only be called by other methods of the same class, that is sibling methods, okay? So therefore conduct survey is not callable here, it is giving error, okay? However, the do assignment can very well conduct call the conduct survey. So it can say, it can simply call the conduct survey. Okay, so conduct survey. Now should we provide s3.conduct survey? We don't, because the client of do assignment is s3, so therefore it is calling a sibling method conduct survey, which is private. That's okay, but the client of do assignment becomes the client of conduct survey automatically. So since we said s3 dot do assignment, so s3 is the client for this do assignment, so and conduct survey is called here, so therefore for this particular conduct survey call, s3 will be the client too, so therefore we don't need to tell that. Okay, so we cannot tell that. Automatically the client of the caller method becomes the client of the called method in case both of them are method of the same class. Okay, so now first it will print conducting survey, and then it will print doing assignment. And now we can call the do assignment, but we cannot call the conduct survey. But do assignment will call the conduct survey, and it will print conducting survey and doing assignment. Okay, so if we wrap it up, we have seen that the fields and methods are by default public in structure. In class, fields and methods are private by default. Okay, however, to call the methods of a class or structure, they need to be public. So if the fields are private, then the fields cannot be accessed anyway from outside. So the only way to manipulate the fields is allowing the methods to be called from outside. So the outside functions in case of main cannot directly manipulate the fields of the class, so it can call the methods, and in turn those methods will manipulate the fields. So you are actually restricting your fields from direct access to outsider. The class actually protects the data fields. Okay, so that's called data hiding. Okay, so in class, so this is one of the major differences between structure and C++. So in a structure there is no data hiding, though you can call the methods of a structure to manipulate the fields, but you can also manipulate the fields directly because fields are also public. In case of class, everything is private, so nothing is usable, so therefore you can at least make the methods public, so that even though the fields are private, you can actually manipulate the field indirectly by the public methods. So anybody can call those public methods to actually manipulate the private fields. Now the question is, in class, should we keep the fields also public? We can if we want to, if we wish to, but object-oriented principle suggests that unless it is extremely necessary, don't keep the fields public. So that gives extra protection of your data, and you empower the class to manipulate the fields. So for example, instead of reading the grades from outside and calculating the CGPA, I can actually keep the grades private, and I can actually call a public method calculate CGPA. Okay, so that way calculate CGPA don't do any harm to the grades, don't change the grades, because it's the method of the same class, it's part of the class. And as an outsider main method, even if the outsider method has a bad intention to change the or modify the or accidental change of the fields, we cannot do that. Okay, so now the big question, which one to use? Shall we use structure or shall we use class? Now as I said, both structure and class, first of all, we want to represent a collection of heterogeneous data, so we use one of them. Now if our only purpose is to represent a collection of heterogeneous data and treat that object like an array, okay, so like an array we can use, let's say, using the elements, using the index. Okay, so we can access elements of an array using the index. So similar way we can access the elements of an object using the dot. Okay, now instead of index we have to use dot. Okay, so if the array name is ARR, we can say ARR0, ARR1, ARR2 to represent the elements of the array. Similarly, if S1 is an object, we can say S1 dot field 1, S1 dot field 2, S1 dot field 3 to represent the data. Okay. So if we simply want to treat it only as a collection of different data, then structure is good enough. Structure is a better choice. Okay. Also, we can use structure to maintain the legacy. Suppose in C++ class is introduced, but in C there was only structure. So if you have some functions, or if you have an application written in C programming language, and if you want to extend that in C++, because C++ is a superset of C, you can do that. But since of the pre-existence of some structure, because in C there was no class, then you can choose to add additional structure. Okay. However, data production will not be there. Okay. On the other hand, if we want to treat the object as a real world instances, and typically oftentimes real world instances are not only mere collection of data, different types of data. Real world instances also have some capabilities. Okay. So for example, a bank employee can calculate the EMI. Okay. A student can calculate its own CGPA, things like that. So therefore we can add the methods. If we need to add methods, if we need to add functionality to the object, then I would prefer class, though you can add methods to structure as well. Using class also gives you flexibility to transit. Okay. So if you want to make a transition from C++ to other object-oriented programming languages, for example Java, Java don't have structure at all. So in Java all you have is classes. Okay. So therefore if you use class, then it becomes easier to make the transition from C++ to Java. And also class gives extended support better than structure on object-oriented concepts like inheritance, dynamic polymorphism, etc., which is out of the scope of this video. Okay. So that's it for the day. So if you found this video useful, or if you felt it interesting, consider subscribing and look out for future videos. Have a nice day and see you in the next video.